Okay, what our lesson is about today is solving system of linear inequalities. Okay, but before we solve system of linear inequalities, we need to know what is the system of equations and how did we solve it. Well, we solve those three ways: by graphing, by substitution, or by elimination. What we want to look at today is how do I solve this by graphing. Do y'all remember how to solve it by graphing? You just graph them and you see if they had an intersection. So you go to your home screen, go to New Document, don't save your last one, add the graph, and then graph the first function. F of x or y is equal to, you might want to follow along with me, 3x plus 4. Hit enter. And then graph y is equal to, so how do I graph another function? I hit tab. And then I graph y is equal to a negative 1/2 x, so that's negative 1 divided by 2x plus 3. And I see where they cross. Wherever they cross, right, is my solution. So when they cross one time, what does that mean? If they cross one time, it means I have one solution. If they don't cross ever, what does that mean? No solution. Right? And if they fall right on top of each other, two lines, that means there's infinitely many. Right? Y'all remember that from this chapter. You're going to take a test on this real shortly, so hopefully you do remember. If they intersect like this one, it means they have one solution. Can you tell me where that one solution is? How do I find that one solution in my calculator? I go to Menu, Analyze Graph, find the intersection. You remember that? And then just move that to the left and to the right of it. And what do I get that to be? It's approximately a negative 2.87. No, 0.287, sorry. Negative 0.287. And then my y would be about a 3.142. So there's my x and there's my y. You got it? Okay. So what's different today? Well, what's different today is we're going to solve a system of inequalities. If this is a system of equations, it means that my two rules, function rules, have an equal to. That's what an equation is. But if it's a system of inequalities, then I would have an inequality symbol, like a less than or a greater than or a greater than or equal to or less than or equal to. So how do I solve this system of inequalities? By graphing. That's the only method I'm going to teach you. Well, how can I graph in my calculator these? Well, I've already got the two lines, right? I got a y is equal to 3x plus 4. A y is equal to a negative 1/2 x plus 3. But I don't have the inequality symbols. How can I graph inequalities in this calculator? When I graph the inequality, you just go to Tab. And I can go up here and change this to not be an equal to, but this one needs to be a what? Greater than or equal to. So I can just go over here and go delete. And change that to a y is greater than or equal to, which is number 5. All right? And then what is it greater than or equal to? A negative 1/2 x plus 3. And there we go. You got it? And how do I graph the other one? Well, that would be a y is less than. So it would be a y is less than. So I just type in y is less than, which is control enter, or control equal to, sorry. And that would be y is less than. That's that second one right there. Just hit enter. And then 3x plus 4. And there it is. Well, what is that? Well, there's my two boundary lines, but they graded less thans and greater than. So what happened is when I graphed my first one, which is y is less than this 3x plus 4, okay, I graphed that inequality, 3x plus 4, and then I shaded in the values that were below that. And also, when I graphed my other one, which is this negative 1/2 x plus 3, I shaded in the values that were greater than or equal to that. And so wherever they overlap is the solution, which means it's a point. It's points. All these are points in that double shaded region right here in the top right of my screen that make both inequalities true. For example, this point right here, which is at 3, here's 1, 2, 3. I don't know if you can see that. 5. Right there where my cursor is. You see where that little hand is? That's at the point 3,5. At that point 3,5, that is a solution to this system of inequalities because the point 3, 5 is in the double shaded region visually, but it's also a solution because it is a x and a y. It is a point that makes the first inequality true and the second inequality true. Let me show you why. If I were to plug in an x and a y, and my y is 5, and see, is it less than 3 times x, which is 3, plus 4? If I plug in that x and that y into that inequality, does it make it true? Let's see if it does. Is 5 less than, what's 3 times 3? 9 plus 4 is 13. Is 5 less than 13? True. So do you see how that x and that y made the first inequality true? Does it make the second inequality true? I don't know. Let's see. Y, and what is y? 5. Is it greater than or equal to negative 1/2 times x? And what is x in this problem? 3 plus 3. Is 5 greater than or equal to negative 1/2 times 3 plus 3? Well, what is negative 1/2 times 3? Negative 1.5 plus 3. And negative 1.5 plus that 3 would be what? 1.5. Is 5 greater than or equal to 1.5? Is that true? Yes. So algebraically, that is a point that makes the first inequality true and the second inequality true with pencil and paper. But visually, what is it? It is a point in the double shaded region. Do you understand that? That's what we're doing today. So how do we do that with pencil and paper? That's what's next in our notes. Okay? So go to your notes and let's look at problem 1.